This is actually the fourth lecture that I've given to the college on the topic of English, the history of the English garden. And the college supported my research when I was provost, and it's a delight to be back here at an institution which I loved leading and for which I have continued affection and respect. In those previous lectures, I discussed the overall growth of English gardening since 1660, the making and running of the great gardens of the 17th and 18th centuries, and the entrepreneurs who designed and built gardens or ran the nurseries which supplied them. My interest in this topic stems many years back, I can't even remember when, from a simple question which I asked as I wandered with my wife around a huge and beautiful garden. And the question was, it's lovely, but how much did it cost? And I found that none of the thousands of books on garden history, none of the guidebooks of the National Trust or English Heritage, none of the books in my own discipline of economic history answered or indeed even asked that question. So I set out to answer it for myself, and this book is the result. It is, in essence, a history of the garden industry in England since 1660, or at least of a lot of aspects of the garden industry. I had to leave other things out. I think I can claim that it is a new kind of garden history, because garden history has traditionally been much concerned with the design of gardens, and that's not my speciality. But tonight I'm going to discuss one aspect of the gardens, which is the technology of gardening and its effect on our lives. One might call it what gardening has done for us, except that I'm not going to talk about the most important answer to that question, which is the pleasure that gardens bring to our lives. And we have to remember that that pleasure is shared by millions. 50% of the British population describe themselves as gardeners. It's by far the largest leisure pursuit, other than watching television or reading or using the computer. And as an outdoor pursuit, it dwarfs any form of sport or other recreation. So it is a very big activity, and as I demonstrate in the book, it's given rise to a very big industry. Now, when one mentions the technology of gardening, everyone thinks immediately of the lawnmower. Actually, it was this, the first working steam engine, that was the first modern machine to be used in English gardens, less than 25 years after its invention. Historians of the steam engine have failed to notice this fact. Wooden water wheels had been used in gardens, of course, for centuries or possibly millennia, probably millennia, but this metallic forerunner of the Industrial Revolution, the first great machine of the modern age, was a new departure. Savory's engine was designed to pump water from mines. But in the flatlands of southern England, pumps were required for a different purpose, and that was to power the fountains, which everyone, every aristocrat at any rate, every rich person, wanted to have in their gardens. And Thomas Savory saw an opportunity, as did his successor, Thomas Newcomen. Savory's engine had a short life, owing to a tendency to explode. But by the middle of the 18th century, Newcomen's engines were widely used in gardens. One was being installed when the great garden designer Capability Brown took up his post at Stowe, for example. Savory's engine is an example of borrowing a technology designed originally for a different purpose. The lawnmower, on the other hand, is an example of borrowing an idea. Edwin Budding saw a cylindrical machine being used to cut the nap off woolen cloth, and he wondered if it could be applied to grass. And ultimately it was, and it put an end to the back-breaking task of scything the lawns of our stately homes. This is at Hartwell House in Buckinghamshire. As with Savery's engine, Budding's idea took decades to be perfected, a feature often neglected of a great deal of innovation. In his case, he had to adapt a stationary machine, cutting wool in a factory, to become a mobile machine. And there was a big problem in making a machine that was sturdy enough to do the job, but also light enough to be manoeuvred around a lawn. The initial solution was a horse, pulling while a man pushed and guided the machine. The machines themselves were very expensive. Early models cost the modern equivalent of £8,000 to £10,000, not including the horse, whose leather shoes, incidentally, which you can just about see in this picture, because the horse had to wear leather shoes to protect the lawn, otherwise it would have cut up the lawn, obviously. Its leather shoes alone cost in one advertisement £660 in modern currency, so an expensive activity. So you've got pumping engines and mowing machines, technologies borrowed from other activities which assisted the gardeners of England. But I actually want to discuss three technologies that emerged from gardens to have much wider ramifications in all our lives. They're concerned with water, with fire, and with light. Economists often find it difficult to explain the processes of invention, despite decades of research into it. Invention is defined as when the germ of an idea emerges. And then innovation is defined as the turning that germ of an idea into reality. Explaining invention can be like trying to explain the music of Mozart or the writing of Jane Austen. Innovation is somewhat easier. Often one can chart the course of an innovation through a complex interaction of the idea, the invention, and then the supply and demand for the ultimate product. But there are always problems because you can often argue that a new technology could have appeared by some other means than it actually did. But what I'm going to do this evening is to follow what actually occurred, and to look firstly at water. When Charles II took up his throne in May 1660, he had quite a lot of things to do. He had to re-establish his monarchy, reassure the Church of England, which was still suspicious of his Catholic roots, appoint ministers, placate people seeking jobs at court, and pursue the regicides. But he had another priority: gardening. And soon after his return to England, he set unemployed soldiers to work to dig a rectangular lake, which he called a canal, in St. James's Park, and you can see it on this slide. This was long before the building of the transport canals of the 18th century. His canal was big. It was 850 yards long by 42 yards wide, and when it was complete, it looked like this. And Evelyn and Pepys record how fond the king was of wandering in the lake, wandering around the lake, and they particularly record how Charles II and his new queen, Catherine of Braganza, walked in the park in the winter of 1661 to watch the sliders, skaters, a new invention introduced from Holland, on the lake, as well as to see the waterfowl. The pelicans introduced by Charles are still, of course, a feature of the lake, although it's been altered since these pictures into its modern sinuous form in the early 19th century. But there are no longer vultures, golden eagles, cassowaries, and ostriches, which he also imported. But apart from the menageries, which were an important feature of 17th and 18th century gardens, and the waterfowl, water is a really essential feature of English gardening. Charles II soon also created long water at Hampton Court, and his successors constructed similar water features, as they would now be called, at Kensington Palace. But the real growth of lake building across the country took place in the gardens of the aristocracy, as they emulated their kings and their queens. And by the end of the 17th century, 30 or 40 years after the Restoration, 40 years after the Restoration, decorative canals of various sizes and shapes, but mostly rectangular, almost all rectangular, had been dug all over the country. And soon they were embellished with garden buildings, as with the beautiful Thomas Archer Pavilion at Rest Park in Bedfordshire. This picture illustrates one of the main aims of waterworks at this period, which was the creation of reflections. They sometimes resorted to even more amazing feats of engineering to create water meadows to provide even greater opportunities for reflections. This is in Bedfordshire, but in the Midlands, in Derbyshire, Chatsworth soon had its canal. This is a picture, modern picture of the great Emperor Fountain, which was placed there in the 1840s. But the canal and the fountain were there as early as 1675. And the canal complemented the other great water feature at Chatsworth, the Cascade, built by the French engineer Grillet for the first Duke of Devonshire. It was and is fed by pipes from a 9-acre reservoir in the hills high above the house and garden. But the apogee of early 18th century water engineering was further north at Studley Royal in Yorkshire. This was the creation of John Aislabie, who was the Chancellor of the Exchequer, disgraced and at one point imprisoned in the Tower as a result of his part in the great financial scandal of the South Sea bubble. He was fined a very large sum of money, but still had an awful lot left, and he created what is still, I think, the greatest water garden in England at Studley Royal. It was complemented when later in the 18th century his son acquired the ruins of Fountains Abbey higher up the valley. Now, I could go on in this way, showing you beautiful pictures of English gardens, but you may already be asking, what on earth has this got to do with technology? The answer is that these waterworks, and many others around the country, were feats of civil engineering, massive feats of civil engineering. And in the process, they transformed our countryside. They were complex creations. And their most important and complex features were the twin technologies of dam building and of puddling, which I'll come back to in a minute, which together made the canals and lakes watertight. But it's crucial to realize that there are few, if any, natural lakes in England south of the Lake District of Cumbria. The lakes which adorn the south and the Midlands, and up into Yorkshire in this case, are artificial. They're man-made. Although very few people realize that. Most people who tour these gardens think of them as natural features of the landscape. They aren't. Nor, of course, are the reservoirs which followed them, using the same technologies in the 19th and 20th centuries, and nor, of course, are the gravel pits, which have become other water features mostly in the 20th century. Now, these canals and lakes of the earlier period, the 17th and 18th centuries, were formed in one of two ways. The first way, which was used in St James's Park and Hampton Court and many, many others, was to dig the canal out by hand. Often they linked together earlier, and this happened in St James's Park, earlier artificially created ponds, often usually for fish ponds. But of course, if you dig out a canal of the kind that I've shown you earlier, you've got to supply the water. So you have to have a piped water system from a convenient, hopefully, water source. That's one way of creating these lakes. The second was to dam a stream, if you could find a convenient stream on your land, and wait for the water to fill the area above the dam. It was more complex than that because, of course, the water can't be stagnant. It has to flow. And therefore you have to create a means of getting the water in at one end and out at the other. All this work used huge quantities of labour. Most of the canals weren't very deep, but if you work out how big and how deep, for example, the lake at Hampton Court was, it meant digging up and carting away about 500,000 barrow loads of soil, and then making the whole thing watertight, as I'll come back to. Building a dam, without any machinery, of course, was equally arduous, and this diagram shows the construction method used by the great landscape architect Lancelot Brown at Petworth, and essentially it is the method used in most of, if not all of the dams of the 18th century, and for considerable long periods afterwards. So what you're doing is piling up soil on the left-hand side, and then on the water side reinforcing that soil with clay, sand and stone to hold the water back. And you can see also a feature of many of designs of the lakes which demonstrate how artificial they are, if you like. The oak door at the centre, which meant that you could raise and lower a door in order to drain the lake or to reduce the water level. Why would you drain a lake? Well, there were two reasons for doing that. The first is to remove the silt which builds up in the lakes, and I'll come back to that one. The second was to make it easier to net the fish. Dams of this kind developed, and the technology is developed exclusively for gardens, become ubiquitous. And they were used, essentially, this method to construct the reservoirs which topped up water levels in transport canals, and that's such as the dam at Whaley Bridge, which nearly collapsed in the last few months. So the technology is developed in the gardens, but because it is developed in the gardens, it has to be unobtrusive. The garden dams were not meant to be obvious. They were meant, these lakes, to look like natural features. And the dams are often actually quite difficult to find. This is Brown's Dam at Blenheim, stretching to the trees in the distance, and looking, as it was intended to do, like a river bank. Behind the photographer is another feature of much 18th century water engineering, the Cascade. Entirely artificial. It's the outlet from the lake in order to let the water flow, which has been turned at Blenheim into an entirely artificial foaming cascade, which is actually one of the great attractions of the gardens at Blenheim Palace. Now, both dam and cascade have to hold back an immense weight of water. Here you can see the southern part of the Blenheim Lake with the cascade at the bottom and the palace in the top right-hand corner, but there's quite a lot of the lake to the north, above the top of this picture. So you can see that holding back the water of 150 acres, a lake of 150 acres, is a major civil engineering task. Few lakes are as large I don't think any is as large as the 150 acres of the Blenheim Lake, but some dams were much, much longer. At Combe Abbey in Warwickshire, for example, the dam stretched for half a mile. Many lakes were designed by Brown to imitate a slow-flowing and winding river. Others had more complex shapes, and this is one example, the two lakes and canal joining them at Wotton in Buckinghamshire, one of the least known, but in many ways one of the most interesting of landscapes attributed to Brown. Here you've got two bodies of water down here, sorry, this is rather difficult to, and here, which are actually at different levels and flow in different directions. So you've got a dam here and another dam here, down here. Sorry, it's difficult to control the pointer. And they're connected by another artificial feature, the canal in the middle, with the engineering carefully concealed under bridges and boathouses. And your eye is taken away from the engineering, if you like, by these eye-catchers, temples, and other constructions in the next to the lake. I'll just go back for a second. One point to notice is how huge these constructions are in relation to the houses which they accompany. And that's where Wotton House is. It's now the stable block, or the carriage house, is where Tony Blair now has his country residence. But you can see how small, essentially, it is compared to the huge scale of the great garden. The artifice of these lakes, which we now think of, as I say, as natural features, although they're not, also, of course, depended on making them watertight, where they're not on already impermeable soils, because lakes which leak aren't much use. Some of Brown's lakes did leak. There's one account, I think, at Harwood of a hole big enough to drown a horse in, from which the water was leaking. But if you got it right, then you could make these lakes leak-proof. And the technique for doing that is another important part of civil engineering developed in gardens, is puddling. Puddling is seen here being used to restore a canal bed, because many, if not most, of the canals are puddled. Puddled clay linings are produced by beating clay with large hammers and then laying it layer by layer. You could often have 8 layers interspersed with lime and stones to form an impermeable base and the sides for the canal. Because it not only had to hold water in, but it had to repel rodents who might try and burrow into it and make it leak. Sometimes oxen were used to trample down the clay. At Lake Pichola in Rajasthan in the 14th century, they used elephants. Brown mostly used humans equipped with special spades for the purpose. Now, the importance of this invention of puddling, or this use of puddling, is that canal historians and civil engineers usually attribute the technique of puddling to James Brindley, the great canal builder of the 18th century. But that's nonsense. It had been used in gardens at least a century before. It may in fact be a Roman technique, but it was certainly brought to perfection in England in the canals, the rectangular ponds of the gardens of English and, of course, also in French aristocrats, and only later transferred to the building of the transport canals of the Industrial Revolution. Brindley's Bridgewater Canal, which was the first example, didn't open until 1761, decades after the garden waterworks which I have described. Puddling was used to waterproof the 150 acres of the Blenheim Lake. Brown had to use 100 workmen for 3 years to do it. and it cost the 4th Duke of Marlborough about £35 million in modern values. And this is a part of the result, a drowning, as Brown did, part of the Vanbrugh Bridge from an earlier period when it also had a rectangular canal. If you think 35 million is an exaggerated figure, then look at the fact that Blenheim is about to drain the pond, the Queen's Pond at the far side of the bridge, to remove the silt from that part of the lake, and that is going to cost £6 million to do. So the point I'm making is that the lakes of England and the reservoirs which use the technology transformed our landscape. It's extraordinary, however, that these huge civil engineering works have been ignored by historians of technology and of engineering. A recent book produced by the Royal Institution of Civil Engineers doesn't mention garden works at all. So lakes are the first of my 3 technological legacies of English gardening. The second technological legacy began much more unobtrusively. This is an illustration from a book by the writer and gardener, John Evelyn, the diarist, published in 1691, and it's of a greenhouse. Greenhouses came into use in northern Europe during the 17th century as houses in which to keep the greens. Those were the citrus trees and other tender plants beloved by the Renaissance gardeners of Italy. But they were tender and they needed protection during northern winters. Greenhouses were initially rudimentary temporary structures, but soon became larger and permanent. But the point of this picture is to illustrate the fact that Evelyn's greenhouse is the earliest English example of the second innovation from gardens which has changed our lives, and that is central heating. And you can see that hot air from the boiler is taken in pipes under the building to heat the greenhouse. Greenhouses rapidly became more elaborate, as here at Kensington Palace, and the term orangery began to be used for them. Even such structures, much more substantial structures, couldn't keep the greens warm enough to survive the winter, and heating was needed. At first, at the same time as Evelyn's invention, charcoal braziers were often used, but these had a problem. Their fumes poisoned both the plants and, in some cases, the gardeners. And that's why John Evelyn and others devised greenhouses with indirect heating sources, the boilers outside the greenhouses feeding hot air through pipe systems into the houses. Now, again, like puddling, this isn't really a new technology because, as I'm sure many of you will realize, that's how the Roman hypocausts worked. But it was the first use of that technology for about 1,200 years in England. It was also used in gardens for at least a century before it was installed in industrial buildings in England, and 2 or even 3 centuries before it was used in the domestic house. There was central heating both inside and outside the gardens. This is a hot wall. If you go to some of the large walled kitchen gardens, which are being lovingly restored by people with a very great deal of money around the country, many of them incorporate, usually across the middle of the walled garden, a wall which incorporates boilers and flues heating the wall and warming the air around the fruit trees planted along it. Although hot air and later steam systems were used in greenhouses during the 18th century, a massive development of heating technologies followed in the 19th century in the greenhouses of the period, using hot water in iron pipes. And this was pioneered in houses such as this at Kew. Initially, the pipes were huge, 4 to 6 inches in diameter, which may be one reason why they were slow to be adopted in domestic houses. But small bore pipes were soon developed for the gardens. The first installation was for a governor of the Bank of England in the 1820s or 1830s. And they were adopted in hundreds and thousands or tens of thousands of greenhouses across the country. Greenhouses, conservatories and orangeries. And the people who developed these heating systems, such as this Glasgow engineering firm, soon, during the course of the 19th century, moved from producing central heating systems for plants to producing central heating systems for houses. Henry Hope of Birmingham, which became the firm Crittall Hope, which many of you will have experienced, was another firm at the period whose accounts show a gradual transition from the garden to the house, from heating plants to heating people. But it did take a very long time. Why? One reason, I think, is that plants can't put on and take off their clothes in order to keep warm or to keep cool, nor can you usually, except at great expense, move them closer to or further from a fire. But there's another reason, which was given by Deborah, the late Dowager Duchess of Devonshire. She was asked why the greenhouses at Chatsworth were heated for 2 centuries before central heating was installed in the great house. One had to realize, she said, that plants were much more important than people. So central heating is my second legacy of English gardens. The third legacy also is illustrated by the greenhouses, the buildings of light and air, which are now such a feature of many of our towns and cities. This is an early greenhouse. This would have been something like the greenhouses which were installed at Hampton Court to take Queen Mary's botanical collection brought over from Holland after the Glorious Revolution of 1688. These early greenhouses had a problem. They were suitable for keeping greens alive during the winter, particularly if heated, but not for nurturing plants. And as the plant collectors fanned out across the world, in particular across North America in the early 18th century, and the plants came back and needed to be nurtured in English conditions, gardeners began to realize that you needed more than warmth. You actually needed light and air to make the plants grow. So it became necessary to build larger and larger permanent constructions, providing more light and also to having windows which could be opened and closed, because ventilation was as important as heating. Now, to the men of taste, and gardening was seen as an important aspect of your taste in the 18th century, to the men of taste who were paying for the gardens, permanent buildings had to look good. We should always remember that gardens and greenhouses were as much a part of luxury consumption and show as rolling grassland or sinuous lakes. So the next generation of greenhouses were built like the example at Kensington Palace, which I showed you earlier, or this later conservatory at Warwick Castle, according to the tenets of classical architecture. There was a side benefit, which was that it was soon realized that conservatories and orangeries and greenhouses could be used by people as well as plants. From the middle of the 18th century to the end of the 19th century, and again it's probably true today, no garden is complete without its conservatory. And a very large industry was created to make them. There were, of course, many uses for conservatories, of which Victorian novels tell us amorous encounters were an important aspect. Sometimes the result of building conservatories is overwhelming. This was the conservatory at Carlton House, on the site which is now called Carlton House Gardens, where the British Academy and the Anthaeum and the Royal Society now are. It was created, as you can see, in 1811 to 1812, and demolished in the 1820s with the rest of Carlton House in order to pay for the works around Regent Street. Note that this amazing building is entirely devoid of plants. And there's a good reason for that, because a plant would have had to be very hardy and sturdy indeed to grow without much light, which you don't get through these windows, and with the smoke pollution which hung over London. But there was a more fundamental technical problem which afflicted all the 18th century greenhouses. They had very small panes of glass. This wasn't, as is sometimes thought, because of the window tax, because the window tax didn't apply to garden buildings, nor of the glass tax, because glass wasn't any more expensive than brick, which was the alternative in construction, but it sprang from the technical problems of making large glass sheets and of supporting them on glazing bars, particularly since some of them had to be openable to get air, as I said, to the plants. The first answer came early in the 19th century from the garden designer and writer. He was really a gardening polymath called John Claudius Loudon. He devised a method of supporting glass panes on curved wrought iron glazing bars, and another method known as ridge and furrow glazing, which allowed maximum light to pass through the light to the plants. And this is an early example of his designs at Lodgages, which was essentially a large garden centre in Hackney in the 1820s, with greenhouses which in some cases were even bigger than this, other greenhouses. But it's still using relatively small panes, but it is one of the first examples of glass and iron construction. Later, of course, transmuted into steel construction, which has become such a ubiquitous feature of our towns and cities. There's actually another important feature of Loudon's designs, which is that the glazing bars were interchangeable. This seems obvious to us. If you're going to build something like this, you'd make all the components the same. But actually, the first manufacture and use of interchangeable parts had only been 10 years before this, in the Portsmouth dockyard during the Napoleonic Wars. So, as with the steam engine, gardens are at the forefront of technological innovation. Another innovation which has changed our lives, which is mass production. Other examples soon followed. This picture, it isn't a very good one unfortunately, but it's the only one we seem to have got, is of the Anthaeum in Hove, which was intended to be an early 19th century version of the Eden project. It was intended, I say intended, because although the architect had designed it with a central iron pillar supporting the entire structure, the builders, this is a familiar story, decided to dispense with that essential element of the design, and the building collapsed entirely as soon as its scaffolding was removed. the remains of it actually continued to be a tourist attraction in Brighton for about the next 40 or 50 years. Another architect offered to rebuild it, and this gives you a sense of the amount of money that's being spent, for £8 million in modern terms, but that was refused, so we didn't have it. But the Anthaeum shows how much glass and metal construction could achieve, that is if you didn't remove the supporting pillar. Other enormous, but perhaps slightly less ambitious uses of the technology, although sometimes with wood instead of iron, followed from this. This was the great stove at Chatsworth, a stove called, because greenhouses had stoves in them, built by Joseph Paxton for the 6th Duke of Devonshire. It was then the largest greenhouse ever built, although it was later surpassed by some of the greenhouses at Kew. It was equipped with a tunnel which one can still walk through to carry the coal, which fueled its boilers, without the visitors to the great estate at Chatsworth being troubled by such mundane features. And it was large enough for Queen Victoria to drive through it in her carriage. There were more conventional greenhouses of the period, built for plants rather than people, as in the magnificent Royal Kitchen Gardens at Frogmore near Windsor, built in the 1830s, 1840s, at a cost of modern values of £33 million. The greenhouses contributed quite a lot of that. Now, by this period, in fact, Chance Brothers had developed a method of making larger glass panes, and that made possible even larger structures. And this, of course, is the apogee of the new construction methods, Paxton's Crystal Palace for the 1851 exhibition. It wasn't actually based on the design for the giant stove, but on another earlier greenhouse at Chatsworth. Much of it was actually made from glass and wood in its first incarnation in Hyde Park, but it was still based on the mass production of interchangeable parts. We're used to delays in the production of great infrastructure projects in this country. Paxton built the Crystal Palace in 5 months by using interchangeable parts. England was at the forefront of this technology, acknowledged as the leader in greenhouse and conservatory design and construction, but others soon followed. This is Le Grand Palais in Paris, built for the exhibition at the end of the century. But it was soon applied, the technology was soon applied to other forms of building. This is a building in Liverpool, the first steel-framed and glass curtain-walled building. You wouldn't probably recognize it as such because the steel is being concealed by the stone. But that was built by Peter Ellis in 1864. And particularly in the United States, much larger buildings using the technology became possible. And this is one of the earliest skyscrapers, again based on exactly the same technology. The culmination of metal and glass construction, now back in the country to which it began, can be seen in buildings such as this and so many others around us in the City of London. Now, let me conclude. Tracing the course of a new technology from its invention to its adoption is never easy, as I said earlier. Much depends on serendipity, the kind which led Edwin Budding to adopt an idea from cloth production. Much depends on a whole series of small modifications to original designs, modifications usually made by skilled workmen and women rather than by the grand inventors who get all the publicity and the credit. And often that takes a very long time, as the example of the lawnmower shows. You're talking about decades in which to develop these technologies. It's always possible, as I said, to argue that a new technology would have occurred anyway, or at least that it came about by a different route. But the fact remains that it was the technology of dam building in the service of the lakes of the aristocrats of the Stuart and Hanoverian period, which led to the technology pressed into use in our canals and our reservoirs. So the lakes became fundamental to our way of life, as well as changing the entire shape of the English landscape. It was the greenhouses of Stuart England which began the development of central heating, which has also affected our lives, altered our lives. And it was those greenhouses which ultimately gave us the skyscrapers, which, love them or loathe them, now transform our cities. Behind all this are talented individuals, talented workers, and above all, to the growth of that neglected British industry, the garden industry, now responsible for 11 or 12 billion pounds a year. But to find out more about that, you'll have to read my book.